4-1, Factors and Monomials. First question I want to ask you today is, what are the factors of the number 12? In other words, I want to know what numbers multiply together to give you 12. We know that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. These are called the factor pairs. 1 and 12, 2 and 6, 3 and 4. They're the numbers that multiply together to give you 12. How did you know this? Well, for 12, it should be kind of obvious that you know how to multiply these numbers, the simpler ones, together to get you 12. There are some larger numbers you'll have to find the factors for later. Another way of writing the factors of 12 are 1, 2, 3, 4, 6, and 12. This is the factor list of 12. You're going to use the rules of divisibility to help you find factors of certain numbers, larger numbers, that you don't necessarily know the factors of like we did for 12. I've given you 6 rules that you're going to have to use today, and we will begin with the rule for 2. A number is divisible by 2 if it is an even number. So if it's an even number, 3047, if that's an even number, then it's divisible by 2 if it's an even number. It's not an even number because it ends in 7. 3046 is an even number because the last digit is even, therefore it's divisible by 2. We are going to skip around and not do the rules in order. We're going to look at 3 rules, the rules for 2, which we already did, the rule for 5, and the rule for 10. These rules simply require you to look at a number and make a decision based on how that number is written. For example, like we did in the rule for 2, we looked at the 7, the ones digit. It was not an even number, therefore it's not divisible by 2. We're next going to look at the rule for 5. If the ones digit is 0 or 5, then the entire number is divisible by 5. In our example, 3047, that's not a 0 or a 5. That means the number is not divisible by 5. And finally, the rule for 10. All you have to do, again, is look at the number and make a decision. If the ones digit is a 0, in our example, 3047, 7 is not a 0. That number is not divisible by 7. So the rules for 2, 5, and 10 require you to look at the number and make a decision based on the number and how it looks. No math involved. However, the rules for 3, 6, and 9 involve some math, some interesting math, but you're going to use that math for all 3 problems. The rule for 3 says the iterative sum is divisible by 3. So if we have the number 3047, to find the iterative sum, we are going to take the numbers and we're going to continuously add them together. So 3 plus 0 is 3. 3 plus 4 is 7. Take this 7, add it to this 7. 7 and 7 is 15. And then we have a 1 and a 5, and we will add those together, and 1 and 5 is 6. This is calculating the iterative sum. You are simply adding digits together until you are left with just one number at the end. So the rule for 3 says the iterative sum is divisible by 3. In other words, it needs to be a 3, a 6, or a 9. And as we found the iterative sum for 3047, the iterative sum is 6, which is one of the cases we were looking for. So the number 3047 is divisible by 3. So success there. The next one we'll look at is 6, and the rule for 6 states if the number is divisible by both 2 and 3. So the rule for 6, again, involves you looking at the number, but also looking at some work you already completed. And so we know that the number is not even. 3047 is not even. It's not divisible by 2. Therefore, it's not divisible by 6 because it's not divisible by both 2 and 3. So that would be a no for the 6. And finally, the last rule you're going to look at is the rule for 9. And that says the iterative sum is 9. So again, we look at our iterative sum, the math that we did here. We added up the numbers together and we got 6. as the final total, and that is not 9, so therefore the number 3047 is not divisible by 9. On a side note, those of you who are interested in unique things about math, when you calculate the iterative sum of a number, here we got 6. If you were to divide this number, 3047, divided by 9, the 6, the iterative sum, is the remainder when you divide that number by 9. It's just an interesting side note about the rules of divisibility for 9. Monomials. This is new. The rules of divisibility should have been a review for you, but monomials are a new term to describe something you've been working with your entire year. A monomial is defined as a number, a variable, or products of numbers and or variables. In other words, it has no addition or subtraction in it. If there's no addition or subtraction, then it is a monomial. If there is addition or subtraction, it's not a monomial. And for part of your work today, you'll be using the rules of divisibility. For the other part of your work today, you're going to be deciding if something is a monomial or not. And that's all you're going to do. For example, 7. It is a monomial. It has no addition or subtraction in it. 7. 3a is a monomial because it has no addition or subtraction in it. 7m over 2n is a monomial. It has no addition or subtraction in it. Examples of what makes up a not monomial. 2 plus b. It has addition or subtraction in it. 3 times the quantity n minus mp is not a monomial because it has addition or subtraction in it. So part of your work tonight will require you to decide if something is a monomial or if something is not a monomial. Your homework is going to be on pages 151, problems 16 through 34, the evens, and then 36 to 48, all the problems. 16 to 34, the evens, requires you to do work with the rules of divisibility, and then 36 to 48 requires you to decide if something is a monomial or not a monomial. Please make sure you copy down all the problems completely.